Hello, fellow foodies, and welcome back to Foodie Pharmacology, the science podcast for the food curious. This week, we're going to take a closer look at how technological innovations are changing the landscape of the foods that we eat. Not so many years ago, eating a veggie burger was a rather dull, mushy experience, but today, find plant-based foods in the meat section of the grocery store that actually make a convincing pass at the flavor and even the texture of everything from ground meat to chicken nuggets. These techie foods are made with an assortment of plant-derived proteins and flavors, and a big part of the pitch from this emerging industry is that they serve as a friendly alternative to meat lovers who aren't quite ready to take the plunge into a full vegetarian diet. But one big that I've often pondered is just how healthy can these uber processed foods be, even if they're made from plants? And what about the added sodium and other products that are added to achieve those meaty flavors and textures? Also, what about the waste stream? Is this extractive process sustainable? Wouldn't it just be healthier our bodies and the planet to grow and eat whole fruits and vegetables? Go on and on with my litany of questions. So it's lucky for me and lucky for you, dear listeners, that we have a very special guest today who can shed some much needed insight on this industry and take us behind the scenes of where things like pea proteins to fungal mycelia and cultured meat are transformed into an array of products. Our guest today is Larissa Zimberoff. She is a freelance journalist and an author covering the intersection of food and technology. Her new book, which is Technically Food Inside Silicon Valley's Mission to Change What We Eat, it covers how what we eat is rapidly changing and the startups that are moving that change. Her work has appeared in the New York Times, Wall Street Journal, Bloomberg Businessweek, The Atlantic, Wired, and many more. After working in high tech for a decade, she earned an MFA from the New School in New York City, and she lives today in the San Francisco Bay Area and will gamely try any new food. And I'm eager to learn about what her perspectives are on some of these interesting new foods. So thanks so much for coming on the show, Larissa. It's great to meet you.
Thank you, Cassandra. I'm so happy to be here. I feel like talking to a scientist is going to really get what I'm talking about.
Yeah, well, I love that about your book. You definitely get into the science behind, some of these really interesting and very new technologies. But I want to maybe start our discussion just by touching on what really drove you to write this book. Was it something just a personal drive, or what was it?
Yeah, I went at the end of grad school, my thesis advisor told me I needed to figure out what made me exotic. And as a girl from the San Fernando Valley, Los Angeles, a white person, I didn't easily come up with what made me exotic. And it took me some time. And slowly I figured out that what makes me exotic is that I have type 1 diabetes, which means that I have to pay attention to everything I put in my mouth so that I can take the appropriate amount of insulin at every meal. And it's complicated. I mention in my book that I see through food, that I have X-ray vision. I look at the macronutrients of food. I don't see a donut, although I do see a donut. What I really see is how it's going to hit me, what it's going to make my blood sugar do. I look at fats, proteins, fiber, carbohydrates. I look at the macronutrients of a food. And what I realized was that all of these new foods were so complicated, but also so manufactured that I'm healthiest when I eat fruits and vegetables and no processed foods, no packaged foods. It's easiest for me to manage my blood sugar. So this advent of new food had me concerned. And then all of my friends and family and even strangers always wanted to know, like, what's this mean for me? What's in it? Like, is this any good? Is this delicious? Right? They had all the questions. And I thought, okay, I could marry my quest to look through food and my desire to break it down for people and share sort of my learnings about nutrition. I've had diabetes since I was 12 years old. So I have many decades under my belt to share with people.
That's great. No, I mean, I think you are right in describing it as kind of like this X-ray vision superpower to be able to look at something and think about, okay, what exactly is in this? And that's where things get a little bit confusing with some of these new technological, derived foods. So we know that many of these are plant-based. That's a new term, the veggie burger terminology that I grew up with. But what does plant-based really mean? I mean, is it really taking whole plants and integrating them into these products, or are they going into the lab and separating certain aspects, carbohydrates or proteins? Like, what are they actually doing with these plants when they make these products?
That's a great point that you bring up. Plant-based is sort of the new natural
Mm-hmm.
terminology. It's very much a marketing term. Coca-Cola could be plant-based. Chocolate, I get people telling me that chocolate's going plant-based, and it just means that the milk chocolate, they've taken the milk out, right? So
Mm-hmm.
there's this, licorice used to always say fat-free, but it's because it was just sugar.
Yeah.
So it's like these funny twists. If we looked at the Beyond Meat burger, which uses pea protein primarily, it's just the protein from a pea. So in our mind, we're envisioning this like beautiful, fresh green pea that's so healthy for us that our moms wanted us to eat. When in reality, it's the yellow, dried, field pea that is then this technical term called fractionated. So it's blitzed up, and it's either wet fractionation or dry fractionation, where the protein and the carbohydrates and the fiber are all separated. And it's just the protein that's put back into the burger, which isn't a whole food. It's very little plant-based. You're not getting the nutrients of a whole pea. And so it's this kind of understanding that I wanted to bring to my book.
Now that's so important because, I teach classes on food and health, and one of the things that we talk a lot about in class is that, you know, when you're consuming plants, it's not just about the proteins and the carbohydrates or the sugar that are present, but all of those things that give plants flavor, right? And color. And those flavor and color yielding molecules are actually the molecules that also impact our health, right? A lot of those are polyphenols or anthocyanins, the flavonoids. But in
You're
this
speaking my language.
process, yeah, I mean, what's happening is you have, even for a healthy vegetable like a pea, and not to pick on the pea, this is just a good example of it. But am I understanding correctly that you're pulling just this protein out, but all of those phytochemicals that give the pea its color and flavor, those are being fractionated, removed from the pea protein. Is that right?
Absolutely. I'm so glad you brought that up, because that's actually the bad tastes are usually in the like skin or the color of the pea. I mean, we're talking about the green pea and not the yellow field pea, which is kind of a little different. It's sort of a pale yellow color, but a lot of the flavors in the skin, and we're not getting that. We're not getting those micronutrients, and we're not getting the even deeper level to micronutrients, which you mentioned. It's things that could have antioxidant qualities inside our body. We're missing that, right? So if you think that you're eating a dose of peas, you're not. You're just eating protein, right? You really are just getting protein. And it's funny because a lot of vegetables are fractionated in China, and they actually keep the fiber or the carbohydrates, and they make noodles out of it, right? We don't even get it back. So sometimes we're having peas grown here, and they're sent to China and fractionated, and something sent back to us, but they keep some of it to make noodles. It's kind of a
Yeah.
fascinating process.
I mean, this is something that's, I mean, really, I think my eyes became more open to understanding the global dynamic of food exchange during the pandemic, when a lot of those routes were interrupted. And it is amazing. You can have something grown in the US that's shipped abroad, processed abroad, and then a piece of it sent back. So this idea around all natural, sustainable, it's not necessarily sustainable, and it's not really all natural either. So
Yeah,
it's hard though to differentiate between marketing, right? And
Yeah,
and
it's
and science.
problematic because shipping was very cheap. I haven't paid attention to like how it is
Mhm.
today with all the like problems. I mean, I can't even imagine with what's going on in Ukraine, like what shipping looks like right
Mhm.
now. But it was so cheap, and it's why we would get blueberries from Chile, or just all kinds of fruits and vegetables from elsewhere, and didn't blink at it.
Yeah. Yeah, because of the well, yeah, I think things may change in the future with rising fuel prices.
Gosh, fuel
Well,
prices, yes.
yeah. So I guess one other interesting aspect of some of the evolving kind of that they're not veggie burgers, the Beyond Burger, and these other products are coming out is that they've also started to incorporate something known as heme. What is heme, and how is vegetable-based heme made and incorporated into these products, and why do they put it in these products?
Yeah. So at the moment, we've got it in an Impossible Burger. So they are the sort of famous for coming up with heme, which gives their burger both color change, so the shift from pink to brown, sort of that Maillard reaction, and they also say that it gives flavor, that it sparks chemical reactions in our mouths. It's made using, they have to use GMO to make genetically modified ingredients. They take yeast that will produce a soy lego it's a very hard word to pronounce, lego hemoglobin, and they, because it's too timely to like grow soybean nodules, root nodules, and extract it from that. So they make it in big tanks, fermentation tanks, much like sugar's made, much like many of the ingredients that are kind of base layer ingredients to our food system. And they are taking this genetically engineered yeast, which expels this like soy hemoglobin protein that they then put into the burger. And they said that the burger tasted like crab cakes when it wasn't in the burger. And I have often asked if I can try a burger without heme so that I can confirm it like live and in person. There's a new company out now called Motif Foodworks, and they have a version of heme called Hamami, and it's very similar. I believe it's not genetically engineered, but I might be wrong in the last time I checked. And so people are developing with their version. So it could be that soon we have multiple versions of this, like heme is also iron. It's what's in our blood. It's what's in animals. It's what is part of the reason we like animal meat. And so basically the scientist and founder of Impossible, Pat Brown, figured out that he could replace animal-based heme with plant-based heme and give us still that same rewarding flavor and color change. Now, some studies are out that show that animal-based heme is bad for us cardiovascularly, and heart disease, but I don't know the answer for plant-based heme because there aren't really studies. So one of the things I kind of suggest is that we are in essence beta testers of all this food because we don't have academic tests.
Yeah, that's a really interesting point. I mean, another thing that you bring up in the book too is that a lot of these studies that are put out about the safety of some of these food products are actually funded by the food companies that produce the products themselves. So there's not as much third party validation in some
And
cases.
there's just very few studies done at all. Beyond Meat recently helped with one at Stanford, basically doing a study to see if people that ate Beyond Meat for more than 2 servings a day versus regular meat for more than 2 servings, and what the differences were. But they provided product. They were part of the study. And they're one of the few that's even done that. So it's sort of a knock, but it's sort of, well, at least they're doing something.
Yeah, yeah. Well, that's a it's I'll circle back to this, but the idea that we've gone from this very highly biodiverse food systems to now these global kind of monoculture, monocropping. In a way, this is like the next evolution in monocropping of making these very defined products that are then manipulated incredibly in the lab. But I think what is, I think, stunning and fascinating from a scientific perspective is all the different sources where they've found ingredients that can be transformed into meat-like products. So one of the other ones I was really fascinated with was your chapter on mycelia and on fungal products. And I'm wondering, when again, we used to think of the kind of large fruiting bodies of mushrooms as a way of having kind of a vegetarian option for sandwiches, but it's gone well beyond that. You write about basically mushroom based bacon, and I how does that taste, and how does that cook in the pan as well, and how is it made?
Yeah. So mushrooms are the fruiting body, and mycelium that you mentioned earlier is the underground root-like structure. Sometimes people call it the information superhighway. It's like how the forest talks to each other. It breaks down organisms that, like, trees and animals and bugs, like, and plants, and it just breaks it all down, and it sends nutrients where they're needed. But an example of the first use of mycelium as a protein, so it's also called mycoprotein, is corn, Quorn. And you can find sort of, quote unquote, chicken nuggets in the grocery store, in the frozen section, that are made by corn and include mycoprotein that they discovered in England, like on the side of a river. Flash forward to today, and there are about 5 to 8 startups that I know of that are all growing different forms of mycoprotein. And in fact, some are growing the same exact mycoprotein, right? And so, it's sort of, I guess, like eating beef from one person or eating beef from another person. It's the same basic cow. But yeah, so we've sort of eventually might have like 20 mycoprotein steaks to choose from. And it's grown mostly in big silver tanks, sort of like you might see in a brewery, that needs nutrients to grow. And you end up having this like thread-like mass that eventually the water's taken out and it's compressed into a chicken breast or a steak, or, maybe something we don't even know. Like, I've been told it makes a great crab cake. And mycelium doesn't need a ton of added gunk like gels and binders and emulsifiers, which is one reason I'm actually excited about mycelium. I've tried it in a bunch of different iterations, and I think it's delicious, but meat eaters typically say to me that they don't like it, or that it's not the same, right? And I'm more forgiving. I'm like, it doesn't have to be the same. And so you brought up bacon. So bacon, the maker that I know is in the East Coast in Albany, and they're actually growing it in long trays that have the nutrients below it. And then they have to kind of convince the mycelium to keep growing layer by layer by layer. And eventually they smoke it, they add some flavors, natural smoke, and some, like, there's like 7 ingredients in this thing, and most of it is flavoring, like things, and then they cut it like bacon. And they do have to add coconut oil. So one of the complexities of most plant-based foods today is that it uses coconut oil or palm oil, or sometimes uses sunflower oil, which is a better oil for us versus the saturated fat oils like coconut. But I think the bacon's great, right? It usually cooks up pretty quickly. It usually, if you have to watch these things very carefully. So cooking is a little more difficult. And there is a little user error involved in trying these new foods.
Yeah, that's you thinking about cooking. Yeah, it's just I guess that one of my underlying thoughts about all these technological innovations in the food space and around this idea of health, but they're not always often completely healthy, because again, we talked about the issue with sustainability for planetary health, but also, the requirement of all these additional binders and fillers and oils in order to get that kind of crispness to the food product. And in some cases they're difficult to cook. Some cases they're easy to cook and can kind of fall in that convenience category. But I just can't help but think, why aren't we doing more just to teach people how to cook a good vegetarian meal with whole fruits and vegetables? Why is that so difficult of a move? Or maybe it's because you can't capitalize on it as well. I don't know. This is my bigger esoteric question of like, why do we do these like extraordinary things? Why not just teach people how to cook vegetables?
This is a big deal, and a big deal for me because I have type 1, and there's only like maybe a little over a million in the US, but there's over 33 million with type 2, and even more
Mm-hmm.
walking around with like preconditions, right? And we're living through this pandemic where we all have underlying conditions, and I have to sort of live with the fact that they're always saying diabetes like it's a bad thing, and I have to like try to promote it like some of us are really working hard like to make it
Yeah.
a different beast. But the American diet, so it's not just new foods that are full of binders and
Yes.
gels
Oh,
and
that's
gum
true.
sugars and junk, right?
Mm-hmm.
Ultra processed foods have been here since the 70s and 80s, and unless we look at the American diet and unless we make changes to it, we are going to keep rewriting the same story, and it's just going to get more confusing, more complicated, more difficult to understand.
Yeah.
There other countries do have public health policies that are trying to do more about warnings and labeling. The US is not going to do that. I'm not seeing that's going to happen. Big food is just earning more money. And, like you saw in the pandemic, like we were all buying junk food, right? I'm sure they were
Yeah.
thrilled that we were buying more junk food. And so we walk around, you know, I avoid it for the most part, not always, because I have to. But
Yeah.
we can't expect everyone to avoid it, right? You'd have to put blinders on. You'd have to like, okay, I'm only eating celery and carrots and nothing else, right? We're constantly
Yeah.
surrounded by junk food. And, here we get this layer of technology solutions that are going to save the planet or do less harm to animals. But our health is still a problem because we still have this stupid American diet, and we're selling it to other countries too, right? So we're not just making us sick at home, we're making people sick elsewhere.
Yeah, I think that's a really important point, and especially with the messaging around, this is good for animals. I would argue it's not always good for animals because the level of radiation required to grow some of these ingredients, in particular palm oil. I mean, we're wiping out orangutans in Indonesia from our palm oil cultivation. Soy, is a big issue in the Amazon. I mean, so you can get rid of the ugly pictures of cattle in a concentrated feedlot, but then what are you doing to other places? So it's not always um a simple response or simple solution.
Yeah,
Um,
all of the plant-based foods and all of the cultured foods all depend on crops, and they all depend on the same monocrops that we depend on
mhm,
now. So we've removed animals from the equation, maybe, right? Maybe we can
mhm,
get there where they're gone, and we are improving because of that. But unless we increase biodiversity, unless we really
yeah,
make radical changes, right, which needs everyone to work together, it's kind of awesome to see what's happening with the war with Russia and Ukraine, because you're really seeing like people working, countries working together to do something, right?
yeah,
And to help, or in certain ways. And so, I think our diet is equally as important. And the startups are like really siloed in verticals where they're just looking at their one piece versus having people who are looking at everything and
yeah,
really horizontally looking at what's happening.
yeah. Well, let's talk about some of these other products, because these are just, I mean, it's mind-blowing what can be done today with some of these technologies. And on your cover, you have this beautiful picture of an egg. It's like, and you think of an egg as like a very fundamental, actually it's a very important ingredient for a lot of meals as a binder. That it has a lot of interesting physical properties that make it useful in cooking. And so, how do you make an egg that's not an egg? It's like,
Yeah. A friend of mine works at a food innovation lab at Oregon State University, and she says that the egg is irreplaceable in, food formulation. And it
mhm.
it has been. Last night I made meatballs that were made with like a hemp-based protein crumble, and I used a little bit of just egg mung bean scrambled eggs as my like liquid, and it worked out pretty good.
Mhm.
And so an egg can be made plant-based. Right now, we've got this mung bean scrambled egg from Just Eggs that cooks up, very close to scrambled eggs. There's some algae-based versions and pea protein-based versions that aren't
Mm-hmm.
quite as good or tasty because you've still got that sort of vegetal taste. But in the lab, we've got companies that are working to make singular proteins from the egg. So maybe it's a protein that foams, or maybe it's a protein that's really that really bioavailable protein for the body. So right now, at a couple juice places, one in New York, and one in LA, you can get a protein drink that has non-animal egg protein that's identical to an egg but doesn't come from a chicken. And so they're using precision fermentation. They're using some kind of flora, yeast, bacteria, et cetera, to spit out, to expel this protein that they've decided there's about 80 proteins in an egg. And they've decided that, X, Y, or Z are the crucial proteins that they want to start with.
Yeah. Fascinating. So they're really getting down to the individual proteins in these production lineups. That's amazing.
Yes.
Yeah.
There's a new company, and they're pretty early days, and they're making singular proteins. And I think they're the only ones that I know doing this. They're making singular proteins from animal meat, from beef. And their plan is to sell that base, maybe it's probably like a powder. Usually it ends up being a powder that people get, to plant-based companies to formulate better proteins, right? Because animal meat does have a level of micronutrients and nutrients that our bodies need, but that we don't make, amino acids that are super important that you can get from a vegetarian diet, but you have to be careful. You have to make sure you're really getting all the right things to get it.
Yeah. Well, there was one part of your book where there was, and I can't remember which chapter, maybe it was in the cultured meat, where you wrote about the process starting with a punch biopsy. And so when I think of punch biopsy, I think of a trip to the dermatologist, I like where you basically take a punch out of the skin.
It's exactly what it is.
Wow. Okay. So what are they doing with this sample from the tissue of an animal? Like, how does that then transform into a non-animal based food? Like, what are they doing with that?
So, that there's a terminology thing here that we can maybe talk about later, right?
Yeah.
It's like non-animal whey protein, which is identical to whey protein, but it's not coming from the cow that moment, right? It came from the cow maybe a year earlier, where they did the punch biopsy of the cow. Sorry, this isn't for the whey protein, but for cultured meat, right? They're doing punch biopsies to locate the very best cells, the cells that grow. And they want muscle cells, they want fat cells, they want it all. And then they feed them nutrients to see what keeps growing really well. Because what they want is something that will just grow in perpetuity. So they don't have to keep going back to get these punch biopsies. They could just use one. And if it's the right one, they can just, keep it under, freezing conditions and just go back to those cells and then just like replicate the cells by feeding it nutrients. Just like a cow eats food to grow its mass, these cells eat nutrients to grow its mass. It needs hormones like insulin, it needs amino acids, it needs carbohydrates, it needs its sugars, right? It needs very similar things to how you or I might need food to survive and how animals might need food to survive.
Yeah. Well, I mean, we do a lot of cell culture in my lab, and I know all about this, growing the immortalized cell lines in the lab, and how much you have to control for their to ensure they don't get contaminated. You have to include antibiotics, but what I'm trying to wrap my head around too is how are they growing these cell lines in the absence of animal products? Because most cell lines require fetal bovine serum, which is a kind of, baby cow blood kind of based product. So there's a lot of gray area here, I think, when you're culturing these and then calling it not an animal product, but maybe they're using animal products to start and maintain them. Is that right? Like
they certainly, in the early days, they were all using fetal bovine serum, and it's sort of like the magic cocktail. It's like I take insulin that replicates human insulin, but your body's going to do it better, right? So the kind of extra stuff that's in our blood is what drives growth. And so in early days, they were using this. And I can't tell you for sure, for certain, that they're not still doing that or using it, right? They all say they're working on a plant-based version of this serum. So they're going to take this new plant-based serum and hope that it grows. But they also have to consider that, like you said, antibiotics, right? How can they keep it clean? How can they keep like bacteria from getting in there? It means they don't go too big with their scale, because if they go super big and then something happens, there's just all of these
There's a lot
intricacies.
of complex factors. I mean, I can tell you, we work on both bacteria and fungi and human cells in our lab. And when you're working with mammalian cell culture, which are like animal-based cells, you have to basically douse yourself constantly in ethanol, right? To kind of sterilize your hands. You have to clean your workspace. And you can be incredibly vigilant with even small flasks, and still it just takes one little microbe to get in there and it ruins your batch of cells. So I can imagine that they have quite a lot of challenges to contend with these cultured based meats. And I think that you'd mentioned before we jumped on, there is a company that's going to open the doors to tours. I mean, that would be really interesting to see. Like, how are they going about culturing these? Can you talk about that?
Yeah. So Upside Foods is located in Emeryville, California. They used to be called Memphis Meats. And if you buy my book, they're called Memphis Meats. But if you listen to the audio of my book, I corrected it, which
Okay.
was great. It happened right when I started, working on the audio. So they are, and I've toured the facility. It's a pilot facility. It was basically built. Maybe it cost around $50 million. No one will really tell me, but that's my guess. And some other people have, chimed in on that. So they've built this facility, but it's solely to get USDA and FDA approval on cultured meat, which is just kind of mind blowing. I mean, just imagine if like some rancher had to build like a meat packing plant, right? To get approval to sell meat.
Yeah.
So yeah, they're once a quarter, they're going to open up their building to give people tours. And I'm going to make this point. It reminds me of the Mormon temple, when they build new Mormon temples, and they want them always to be these like magnificent buildings that like put awe, like, right, inspires awe in the people that go see them. And I went to see the one in San Diego after it was built, and they let people in. We have to put little booties on our shoes so we don't muss the carpet. And I was told that they even still replace the carpet, and we get to see it, and then they close it up, and then it's only allowed for Mormons, but they want people to talk about it. They want us to come in and talk about what we saw and the awe and amazement. And in the same way, Upside Foods wants us to talk about these tours, and they want to normalize cultured meat and have us talk about it very early on. So that when in a year or 2 years or 5 years or 10 years, when it finally is out in the supermarket, it's no big deal.
Yeah. Well, I can say this. If companies like this figure out a way to grow mammalian cell culture without antibiotics and without fetal bovine serum, you're going to have all the biomedical scientists in the country knocking on their door like, tell us about these innovations, because as far as I know, in lab science, we're not there yet, at least in the academic space.
Right. I
So,
mean, many people working in food came from medicine, right? They were
yeah.
working on, tissue cell culture for medicine, for medical uses.
Mhm.
And so I'm kind of like, as someone with diabetes, I'm like, could you work on my islet cells first? Could you work on getting me a new pancreas instead of giving me meat? Like, I don't need meat. Like, I'm fine with plants, which is another thing, right? They're spending millions and now billions to create cultured meat. And, like you mentioned, can't we just have more fruits and vegetables? Can't we just change our diet? We're being told to eat less meat, but we're actively working to recreate meat in the lab, doing something that you say that, scientists around the world have not been able to do.
Yeah, exactly. I'm a skeptic, so I have to like put that out there. It's like I mean, I would love it. I would love to incorporate these technologies if they are feasible for growing these without, running into these problems with contamination and
I mean,
antibiotics. I mean, yeah.
I think pharma is going to get involved. Without pharma, like this initially
Yeah.
was a pharma supply chain for them, but that was too expensive.
Yeah.
Drug discovery is too expensive. So now they're at sort of like animal grade nutrients and ingredients, right? And so even that kind of has me like, oh, animal grade. I don't know. There
Yeah.
are questions.
Well, I mean, antibiotics in our food system, period, are a problem. We've seen this in whole animals, with CAFOs and also with our poultry, although there have been changes. It's funny how sometimes changes are made in the industry because a lot of it has to do with labeling and marketing and how things are considered antibiotic free. You can still inject a chicken egg with antibiotics, and that chicken that hatches from that egg is still considered to be antibiotic free, which to me doesn't make scientific sense at all. But it's all about how the terminology is posed.
Well, that's
Um,
great that you bring that up because I know I mentioned this non-animal whey protein, and so you can find
mhm,
that in ice cream on the shelves right now. So there are a few brands that are using this non-animal whey protein, which I'm told helps the sort of the mouthfeel, the creaminess, and it's still dairy. It is not dairy. It is identical to cow's milk. The whey protein or casein
mhm.
protein. These are very functional proteins in cow's milk that we're using. So, like a friend of mine bought the ice cream and was upset when she realized it was dairy. It's lactose free, which is good, but for some, but it's still dairy protein. And so there's going to be a lot of confusion at terminology as we try to like figure it out because it's not vegan because
Yeah.
so a
Like,
lot
what
of
is
questions.
it? It's in this weird middle zone. Yeah.
Yeah.
Well, one other aspect I want to touch on before we finish is the discussion of vertical farming. I mean, because I'm a plant person. I love plants. I spent my career, studying plants and their chemistry. And you bring up a really good point in the book about, the questions that we don't have answers to yet. If we're growing plants in these kind of warehouse environments, like, are, is a tomato, basically, or is basil? Like, is that plant that's growing in this controlled setting of a warehouse, vertical tower without soil, is that going to have the same kind of health benefit or nutrient content that same species, that same cultivar would have growing in a field?
I've asked for data from companies that are vertical farm companies. I've asked for like very
Hmm.
specific data, and it's not easy to get it out of them. Most farms use USDA data that's generic, right? It's not
Yeah.
farm to farm to farm, which would be helpful too, right? Because now we have regenerative organic farms, we have
Hmm.
organic, we have certified organic, right? There are so many shades of gray just to the soil world of what we're actually getting nutrient wise. But if we just think about kale, because it's the example I like to offer, I love lacinato kale. It's really curly, it's really thick, it's really fibrous, it's dark green. And if you buy a package of kale that's from a vertical farm, it tends to be whisper thin and delicate, and the stem is like just a slip of a thing, and it doesn't taste the same. It doesn't have the same fiber. It can't. There's no way it has the same phytonutrients. It's just like very different. It's a different kale. It's not the same. And so, you mentioned I mentioned in my book, there's the microbiome. There's our own microbiome, right? Which we're just sort of tapping into and realizing how important it is. But there's the microbiome of the roots in the soil, and then what that means for our food. Plants in vertical farms are grown in potting soil, potting medium. Generally, it's potting medium that's used once and then it's tossed. And that's like coconut, it's peat, it's just a mix of like, could even be inorganic. One company, one vertical farm uses they do aeroponics. So the roots are just hanging in the air and they're misted, but their seeds are grown in this like blanket. It's like a fluffy blanket made from recycled plastic bottles. Right. And so the roots are white. They're like brilliant and white. Right. And you expect dirt and you expect brown. And I'm not saying that white is bad and dirt and soil are good, but like there are differences and we don't know them.
No, I couldn't agree more. I mean, there was a study that came out of MIT's Media Lab a few years ago on basil. That's what brought basil to my mind. I was thinking of this paper, and they showed like even conditions like, amount of exposure to lights within these box systems really influences the final chemistry, the volatile chemistry, that flavor you have in basil changes with these different, as you tweak these different conditions. And you're 100% right. I mean, the plant microbiome is critical to the plant's development. And, plants not being, motile creatures or sessile, they respond through producing these phytochemicals, these phytonutrients as means of defense. So if there's no pest at all, there's no threat, it's actually, it's if you pamper the plant too much, it's not going to really produce the types of qualities that make it useful to us as humans to eat. So that's definitely a concern. You need to kind of beat them up a little bit and throw some microbes on them, and then you've got a healthy plant. So
yeah, it's like dry farming grapes or tomatoes, right? People do that for flavor, and flavor is how you know something is good for you. Dan Barber likes to say that to me, and I like to repeat it.
Yeah. No. Yeah. It's so on spot. Well, okay. Last question.
Okay.
I know that you definitely are a lover of whole vegetables, whole fruits in your diet and grains. But if you had one product that you would recommend that people try, if they listen to what, this is all very interesting. I'm unsure about these products. But I still kind of want to taste one. Like, what would you suggest? Would it be the whey ice cream, or a burger, or like the corn nuggets? Like, have you found one that you really just enjoyed the flavor of?
Yeah, I think, okay, so like an easy start would be someone trying the ice cream with non-animal whey protein, or there's a very good cream cheese made from a company called Nature's Find, FYND, and they discovered a fungal protein in a Yellowstone geyser that they are reproducing. Okay, so this protein is in their cream cheese, and cream cheese is delicious. They also make a sausage. The sausage isn't as far along as the cream cheese is. Brave Robot is one of the makers of the ice cream with non-animal whey protein. There's the Just Egg mung bean scrambled eggs that I often have. I think I just know that like it's like 98% of chicken eggs come from factory farmed chickens, and it just makes me sad. And so I think egg for me is a really easy one for me to be like, I just don't think I can do this. And then my most recent is Deli Meat. Okay, so I love salami, right? So fatty, chewy. And so there's a company in Berkeley called Prime Roots that is just coming out with a Deli Meat selection, and it's made from koji, which is also a fungi. And so they've got ham, and they've got turkey, and they've got salami. And I got to say, I was pretty happy.
Oh, that's awesome. Yeah, we talked a lot about koji on some of our earlier episodes on fermentation. So for anyone interested, you can go back to those.
Oh, good.
That's interesting. Yeah. Well, great. Well, this was fascinating, Larissa. Such a great book. So for any of the listeners that are curious again about learning more about what's the scoop on all of these new techie driven foods, how they're actually made, how to interpret that marketing language, I highly recommend her book. And you said you also have it out on audio version in addition to hardback.
Great. Audio, and I narrate the audio so you can hear my voice some more.
Awesome.
Yeah. I also have a weekly newsletter that I send out every Friday that's kind of chock full of interesting news and information and like tidbits that I catch my eye, mostly food related, but sometimes not. Sometimes I get excited by sneakers made from pineapple leather or, something like that.
Yeah. And that's at your website?
Yeah, you can sign up at my website, which is larissazimberoff.com. I'm also very active on Instagram. I'm technically.food, and also TikTok, where my most watched video is where I grew a lion's mane mushroom. Pretty fun.
Fun. My lab just joined TikTok.
Good.
Yeah, I'm such a late technology adopter, so it's been an adventure for me, but a lot of fun.
Awesome.
That's great. Well, thanks so much for coming on the show. Yeah.
Awesome. I love the conversation.
Yeah. You've been listening to Foodie Pharmacology, the science podcast for the food curious, recorded here today remotely. And I want to send a shout out of thanks to our producers, to Rob Cohen and Christine Roth of Co-Conspiracy Entertainment. And thank you to you, our loyal listeners. It's been amazing having this show with you. We're now in our 4th season, and you can find all of our old episodes on our website at foodiepharmacology.com. You can also catch the video version of this episode and many more on my Teach Ethnobotany YouTube channel under the Foodie Pharmacology playlist. Thanks so much for listening. Stay healthy out there, and I'll see you next time.